So we're going to take a look at solving equations that involve absolute value expressions. And I'm going to do my best to sound a little more awake than apparently I normally do, so I won't get so much flack from you about that. But it's still the same old math, so that part won't be any more exciting than it is any other time. We're going to break this down into basically three types of absolute value equations, and I'll show you a few examples of each type. So let's get down to business. So the basic absolute value equation, I like to call a variable between the bars. And those equations look something like this. We have the absolute value expression, something like the absolute value of x. I'm going to change the size of my pen here. And it equals a number like 10. And remember, we're trying to find solutions to these equations. What that basically means is, are there any numbers that we can put in for x that have an absolute value of 10? And as it turns out, since we know that absolute value means how far a number is from the origin on a number line, we can basically take this x and plug two numbers in. The first one is x equals 10, of course. The absolute value of 10 is 10. And there's another number as well, and that is x equals negative 10. Right? The absolute value of negative 10 is also 10. And that's going to become a theme as we work through these absolute value equations. We're always going to break into two cases. In one case where the expression inside the bars is the positive version of the value, 10, and also the expression could be the negative 10. And then, as you know, we like to write our solutions as in set notation. And so in this case, we'd have two values of x that work, and that would be negative 10 and 10, so we have two values in our set. So that's the gist of the absolute value equations, where there's a variable between the bars. Let's try another example. Now, when I say a variable between the bars, it doesn't mean it always has to be x. Let's try the absolute value of m equals 140 and see if we can find the solutions to that equation. Well, just like before, there are two numbers that have an absolute value of 140. So I'm going to set the expression inside the bars equal to 140, and also set the expression inside the bars equal to negative 140. And it turns out those are the two solutions. Negative 140 and 140. Now you won't notice it, but I'm going to take a break here for a minute because one of my kids is yelling down the stairs at me. And I'm back. What seemed like an instant for you was quite a while for me. Anyway, let me take one more, let me show you one more example. This one's going to be a little weird, where we have a variable between the bars, and then we'll move on to some more complicated expressions. So let's take a look at this equation. The absolute value of v equals negative 14. We are trying to find values to plug in where v is so that the absolute value is equal to 14. Now, hopefully in the back of your mind you're saying, we can't do that. Turns out it's impossible to do the absolute value of any number and end up with the result of negative 14. That's because when we measure absolute values, remember we're measuring distance from the origin, and that's always a positive value. So in this case, there are no solutions to this equation. In other words, v is an element of the empty set. Okay? There are no values for v that can give us an absolute value of negative 14. So that's kind of like a trick. Now, there are certain times, which we'll find out later, where there can be a negative number on this side, on the right-hand side. But when we get down to the absolute values, if it looks like this, we have to say no solution. So just be ready for a little bit of extra consideration whenever there's a negative number on this side. Okay, let's try some more interesting problems. So these next group of problems I like to call extra stuff between the bars. when I can pronounce it anyway. What that means is there are going to be variable expressions between the absolute value bars. Let me give you an example. Right off the bat, we'll try. The absolute value of the quantity x plus 8 equals 12. Now, just like before, we have to consider two possibilities. It's possible that whatever x plus 8 is actually equal to 12, because that would give an absolute value of 12. So over here, we're going to try and solve x plus 8 equals 12. But it's also possible that x plus 8 might equal negative 12. And then after we do the absolute value, we end up with positive 12. So we have to check that possibility as well. Just like before, there are two cases. Now this time we have some work to do. These are still equations, and we need to use inverse operations to solve them. In this case, I'm going to do minus 8. And actually, I'll end up doing minus 8 to both sides, right? To every side. To both equations, I should say. And over here, the 8's cancel, and we end up with x equals 4. That's one of the solutions. If we plug 4 in for x, we'll get 12. And when you take the absolute value, you get 12. Over here, the 8's cancel. And when we do negative 12 minus 8, that's negative 20. It turns out that's the other solution. So there are two solutions. There's negative 20 and 4. If you're going to write them in set notation, try to write them in ascending order. Put the lowest one first, then the next one, and so on. Okay, so our strategy was the same as before. We circle the stuff that's inside or in between the bars, and then we have to set that, whatever it is, this stuff, equal to this value and also its opposite, right? We have to do negative 12 and 12. And that's how we're going to get two solutions. These are the only two numbers that work, though. We didn't miss any solutions. Let me give you one more example where there's extra stuff between the bars. Okay, let's try the absolute value of 3x minus 9 equals 15. Strategy is the same. The stuff between the bars, 3x minus 9, could actually equal 15, and that would give us an absolute value of 15, so we're going to jot that case down. That's one of the possibilities. But it could also equal negative 15, and we have to account for that possibility. Once we do that, it's all inverse operations from here on out. There's a plus 9 inverse operation here. And the inverse operations are the same for both equations, even though the values will turn out differently. What happens? These cross out. And I have 3x equals 9 plus 15 is 24. Over here I have 3x equals negative 15 plus 9, which is something like negative 6. Then we'll divide by 3 everywhere. Cross these 3's out. And on this side, that's going to be x equals 8. And over here, negative 6 divided by 3. That's x equals negative 2. I have two solutions as we expected we would, and I'm just going to list them here. That was not a very good looking curly brace, was it? I'll try and fix that for you. Okay, strategy is the same. Take the expression between the bars, check and see what happens if you set it equal to 15, but also don't forget to set it equal to negative 15, because that is a possibility, right? The absolute value of negative 15 is also 15. Okay, I wasn't planning on doing this, but I'm going to throw in a third mysterious example that won't take very long to show you. Let's quickly solve the absolute value of 176x minus 214 equals negative 82. I'm pausing for a minute just to see if you can figure it out on your own. You're probably yelling at me because these numbers are, 3 digits and kind of big, and I can't believe I have to do arithmetic with these things, but that's not really the issue. The issue here is that when you have an expression between absolute value bars, the only option is for that to turn out positive after you do the absolute value. So the result cannot be negative. So you basically should say, nope, can't do it. And it turns out this is just no solution. There's no value for x that will make this absolute value equal to negative 82. Again, just pointing out that it's going to happen from time to time and you have to be ready for that situation. Okay, let me show you about our last category of absolute value equations that we're going to deal with. I like to call this category extra stuff outside the bars. Let me show you what I mean. These are the equations that really get fun and interesting. How about the absolute value of 7x plus 14 minus 35 equals 42? Okay, so here's the deal. We do have absolute value bars in this equation, but that's not the most pressing issue. Right now, the most pressing issue is that we have this minus 35 outside. So we're not going to break it into two cases yet. We don't break into two cases until we have an absolute value equation. And so what we need to do first is some inverse operations. So anytime there's stuff on the outside of the bars, minus 35 times by 4, any operations outside the bars, you're going to use inverse operations to deal with them first. So in this case, we're going to do plus 35 to both sides. Always do those inverse operations first. This crosses out, but I'm still left with the absolute value expression, which is 7x plus 14. Absolute value is 7x plus 14. And then if I add 42 and 35, that's what, 77? Yes. At this point, we're down to where we have to address the absolute value bars. And so this is where I say, hey, this expression is either going to equal positive 77 or that expression is going to equal negative 77. I'm off the screen a little bit there. I apologize for that. I guess it doesn't bother me enough to change it, but I did apologize, so that's okay. What are we going to do here? Inverse operations, minus 14. I'm just doing it all at once. And that means 7x equals 63. We'll divide by 7. Oh man, I'm off the screen here. What's this? X equals 9? On this side, cross it out. This is going to be, oh my goodness, negative 91. And I'll divide by 7. And on that side, we get x equals negative 13. And this time I am kind of sorry that this didn't fit on the screen, but this is x equals negative 13. So I do have two solutions, negative 13 and positive 9. The key to these problems is to take care of what's on the outside first using inverse operations. All right, that's the big deal. Inverse operations first before we break into two pieces. Let's look at one more final example. Okay, we're still working with extra stuff outside the bars. How about 2 times the absolute value of the quantity, 4x minus 5, minus 8 equals negative 2. Now, let me point something out to you right now. This, negative 2, is actually not an issue. All right, and I'll show you why. Before we decide what to do with the absolute values, we have to address the stuff on the outside of the bars. And so, what that means is this 2 may not turn out to be negative. And so let's try this first. When we do inverse operations, we deal with addition or subtraction first. So I'm going to add 8 to both sides. And when you see what happens next, you're going to say, oh yeah, I see what he did there. Cross that out. I still have 2 times 4x minus 5, absolute value of 4x minus 5, equals, and now this is positive 6. That's good news, but we're not out of the woods yet. We still have to deal with the 2. This is 2 times, right? 2 times the absolute value of 4x minus 5. So we're going to divide by 2 on both sides. More inverse operations. Once you do that, you're left with 4x minus 5. The absolute value of 4x minus 5 equals 3. Okay, now that is good news. That 3 is positive. We can continue solving this equation. Of course, I've run out of room and I don't want to squeeze it in like I did on the last slide, so I'm going to start a fresh one and we'll finish off this problem. So we left off with the absolute value of 4x minus 5 equals 3. Now we're to the point where we simply need to consider the 2 cases. It's possible that 4x minus 5 could just be equal to 3, and that would give us the absolute value of 3, right? But it's also possible that that could equal 4x minus 5 could equal negative 3, right? That whole value in my blue circle there, blue shape, could equal negative 3. That would also give us a result of 3 when we took the absolute value. We have to consider both cases. Once we get these written out, we do inverse operations like we have for a long time. We're isolating x in both cases. Here we get 4x equals 8. And over here, what is this? 4x equals 2. Ooh, that could be interesting. Let's divide by 4 everywhere. And 8 divided by 4, that's pretty standard. That's just going to be positive 2. 4, let's see, 2 divided by 4, well that's weird. 2 divided by 4, that's just a fraction, but it does reduce. That reduces to 1/2. So in this case we have 2 solutions. One of them happens to be a fraction, but it's no big deal. It's still a real number. So one of our solutions is 1/2, and the other one is 2. Now if you're ever worried that you had the wrong answer, you can always take your values and plug them back in for the x. And make sure you either get a result of negative 3 or 3. So for instance, when I put a half in here, 4 times a half is 2, 2 minus 5 is negative 3, but the absolute value turns it into a 3. That checks out. If you tried it with 2, plug 2 in where x is, right here. 4 times 2 is 8, 8 minus 5 is 3, the absolute value of 3 is 3, that guy checks out. You can always check your own work by simply plugging in your solutions to the original equation and seeing if they're true. Okay, this was my opportunity to sort of give you some examples. Made it in a video form just so if people want to watch it later they can. And hopefully we can wrap up this chapter and get moving on to some more interesting types of mathematics. Good luck with the rest of your studies.